Okay, hello there, guys. I received a question about a year ago. Someone was asking if I want to return an amount of money to the customer. Can a program figure out what combination of coins to return? Okay, usually uh, the question is usually formatted as what are the um, what are the combination that result in the least number of coins, okay, that will give you the same value. For example, you want to pay back 7 cents, you could use 7 coins, or let's say you could use 5 cents and 2 1 cents, resulting in 3 coins instead. Okay, so basically the program will figure out the combination. So now we have this very simple program. Okay, so the program, this is a terminal or console application. The first thing that you see here is that you ask the user to enter the amount, okay, and you put that into the total. You call the function calculate coins, and then you will loop and display that. So far it seems easy, but let's go to the main part here, which is calculating coins. There's a problem usually called the knapsack problem. Okay, you could search on that in the internet. So anyway, so here we're gonna use a technique called the greedy method. There are many techniques, but greedy method will take all possible combinations. We'll see how we do that. Okay, so here we are gonna calculate coins, right? So first thing, sorry, we need to know is to figure out what are the type of coins, okay, that we could use. In this case, we have here we are defining a list of integer. I have a 1 cent, 5 cents, 10, 20, 50. So far so good. Now we have something that will help us figure out what we have found so far, okay, and this will be a list, okay, or an array or a stack. I'm gonna call it possible solutions here. Okay, it's gonna be a list of objects. Each element will be a little bit different. It's not each element will be a list of coins. Okay, so now we will have another thing here, dimension, best solution. Now the best solution size as integer equal total plus 1, for example. Now this will tell us, this will help us avoid going to solutions. For example, if you figured out that you could do the calculation using 5 coins, and then during your search, okay, found another solution that requires about nine coins, instead of going up to the 9th coin, you could stop the search as soon as you exceed 5 coins. Okay, so it will help you truncate the path and go back and find another solution, because you already know it will cost you more. Okay, so this part, this is going to be hopefully straightforward. And what do we have to do also? We have to say dimension best solution as maybe list of integer. This will equal nothing. So basically the best solution so far is nothing. Now we are going to need another thing here, okay, which is a list for the value, right? So in addition, we have to know how many coins being accumulated so far. So possible, I mean the value of the coins. So possible solutions sum as new list of what is going to be list of integer. Okay, so first thing we are gonna do, we are gonna say possible solutions dot add a new list of integer. Now what this does is gonna create an empty solution. Okay, so here we don't have any coin, and obviously the sum for such solution dot add 0. So the sum for such solution is 0. Now what we need to do is the following: do while possible solutions dot count doesn't equal 0, which means repeat the following steps as long as there are other possibilities to be checked. So we make sure that everything is going to be verified, and we make sure we get the best possible solution. So we get into this later on, but basically what happens in the end is we return best solution. Okay, so now we are going to start with this one. So what happens here? What happens is we get the first solution and get all the possible combination for that. So here, get the first solution. Okay, so dimension one solution as list of integer. Now here this should equal to possible solutions of what? Of 0. There we go. Okay, and dimension one solution cost, one solution sum as integer equal possible solution sum of 0. So now we just got the first solution and put it in here. The next thing we need to do is to remove it from the list. Okay, so possible solutions dot remove at location 0 and possible solution sum dot remove at location 0. Now you might be wondering, we remove that, so the solution we just put, which is already empty, has been removed. Well, this is because we are going to check and work on that. So now we will put this condition if. Okay, so here we just put if one solution sum is greater than total, okay, then just do nothing. Don't process that any further because this is a failed route. Okay, the second case is else if. Now if one solution dot count, which means the number of coins in this solution, is greater than, okay, best solution size, okay, in that case we don't have to continue because this means we will use more coins. In that case also do nothing. Okay, now else if one solution sum equals total, which means the sum for the current solutions is exact, and one solution dot count is smaller than best solution size. In that case, we found a better solution, a better combination of coins, a smaller combination of coins. Then we need to replace, so replace the best solution. In this case, how do we do that? We just say best solution equal one solution, and best solution size equal one solution dot count. There we go. And we don't have to do anything. Now, the last possibility is if there is nothing else to do, this means we don't have enough coins, so we will have to find all the possibilities and work based on that. How do we do it? We do it like this. We already have the list of possible coins stored in coin types, so these will be added. So now we will add all combinations. Okay, so dimension I as integer. Next is for I equals 0 to coin types dot count minus 1. So here we will take into consideration all the coin types. What we are gonna do here is dimension a new solution. Actually, this is a new possible solution equal one solution get copy, right? Let me see, is there a copy function? Yes, a system collection. Yeah, copy to array, index array. Oh, we will have to do a manual copy of these values, right? Let me see if there's another. Yeah, so I will have to copy the list. I'll create a very quick function here. Just bear with me, please. Public function copy list. Okay, L as list of integer as list, sorry, of integer. There we go. So now dimension L2 as a new list of integer for each ITM in L, L2 dot add ITM and return L2. So now we have just finished the function. This function will simply copy the list, so here our work will be much easier. It won't be confusing. So here copy list on solution. So this is the new possible solution. Now, what's the difference here? Also, we need to modify it because right now this is exactly the same previous one. So new possible solutions dot add, we will add a coin to it. So coin types of I. This is the first thing. So now we have a new solution. Next, we say dimension new possible solution. New possible solution sum equals, what was it, one solution sum. We add to that coin types of I. There you go. So now we not only added one coin, we also updated the sum. Now this one, since it's one of the possible solutions, we will add it to the list. So here we have possible solutions dot add new possible solution. There you go. And possible solution sum dot add new possible solution sum. That's it. Okay, so we added, and since we have a loop, we will put all the combinations in here. Now Okay, so continuing our tutorial. So basically now our code uh, is finished. So all we need to do is run and see if it works. Okay, so now I'm gonna run this. Hopefully it will work. And I found. Now I will start with something simple like 1. Obviously it's 1. Wait a second. It was good I tried that because the terminal will disappear right away. So console.readline. Okay, this will be used to keep the screen. So now I will use 2 coins. There you go. So you have 1 coin, 1 coin. Now I will use 5 coins, and obviously a 5 coin. Now I would use 6 coins, and it can figure out. Now let's use let's say 17 coins. Sorry, 17 cents, and 2 ones, a 5, and a 10. Okay. Yeah. Okay. So this is how you could do. This is how you could do it. Yeah. Now I will modify this a little bit and make it display a little bit more. Okay, so instead of asking the user, it will display all possible combinations here. So dimension total as integer, and for total equals 1 to I'm not sure, maybe 200 cents. Maybe make it 100. Okay, and put a next here. Right. So before anything happens, here as soon as you read that, I will say console.write. What do we write here? Total and cents. Okay, and VB tab. There we go. So you can see at each line how many coins to be used. So I'll save this here, and I will run this. Okay, you can see. Yeah, let me stop this for a sec. Okay, if tab. Okay, after I forgot to say console.writeLine. This one is important because here, after writing the numbers, we need to go to a new line in order to prevent displaying multiple results on the same line. Okay, so now I'm gonna run here. Okay, and there we go. You can see that displaying the first few worked perfectly fine, but later on, what happened? You can see the computer's taking more time. And the reason the computer is taking more time, it's trying the number of probabilities increases as the number of coins increase. Okay, so you could navigate this up the very beginning and have a look here. So you can see 1 cent requires a 1 coin, 2 cents, 2 coins, and so on. 5 cents, 6 up to 9, and then you have the 10, the 15, and there's the 20 coins, and so on. So so it's quite nice to see that a computer could help you with that, but the problem right now is with the speed of the algorithm, and this is to be expected. Okay, the reason for that is actually we used a greedy algorithm, and a greedy algorithm takes all the combinations. Okay, So this is why it's taking too long here. Okay. So while this one is working, we can do very simple tricks. Okay. What I'm gonna do here is not like one of the algorithms or one of the techniques to improve, but rather something related to what we have done here. So if you look at the code here, we are checking the sum and we are checking the number of coins here, right? So what we could do is, instead of making this this solution start with this problem start with an empty solution resulting in checking every possible combination, we will improve it a little by finding the first solution, okay, and then make it start from that one, okay. So now I'm gonna add to it a little bit, okay. This part is added to improve the speed of algorithm, okay. And I'll just put number of axes here. You could avoid this part altogether, but you know. So we are gonna find a very simple solution here, okay. So now, instead of doing it like this, the best solution, well, I will have to, okay, so dimension tmp also new list of integer, okay. So this is going to be our new, this is going to be our first solution. This will be the holder of our first solution. So dimension tmp sum as integer equals 0. Now do while tmp sum, okay, is smaller than, okay, do while tmp sum is smaller than total. So what are we gonna do? We will start adding coins, okay, starting from the largest, okay, and okay, if it is possible to add a large coin, we will keep adding the largest coins, then we will go to the next ones, okay. So this is what are we going to do. So dimension I as integer for I equals, now we will search the coin type dot count -1 to 0 step -1. Okay, why we are starting from the end of the list? Because the largest is at the end. So now if coin types of I is smaller than or equal what we have total minus tmp sum, then what this condition means is if this coin okay is smaller than or equal to what it is needed to get the total, in that case what we will do, we just say tmp sum equals tmp sum plus coin types of I, this is first, and then we will say tmp dot add coin types of I, and after that we must say exit sub, exit 4, I'm sorry, exit 4. Okay, so this will work without a problem, but when you will exit this loop, you will have in tmp and tmp sum the best one of the solutions. You can start from there. So now we will modify this a little bit. Yeah, so I will put this one here. Now this is gonna be what? This is gonna be TMP, and this is gonna be TMP sum. Okay, right, so we are after doing this one. Let me just check that it's gonna work. Okay, so best solution size, I forgot to set the best solution. I'll have to say what best solution. Yeah, I think this will do it. So I will save this work and run again and see if this would work. As you can see, we almost didn't wait at all. Check this out. Already got the 100 solutions right away. And the reason for that is you provided the first solution. We already truncated most of the search paths, resulting in, whenever the computers try to go into a new combinations that does not satisfy, it will cut it right away. Okay, and actually you can even increase that. Maybe we could just put an extra 0 here and run, and now we got the calculation up to 1000 cents. Okay, so $10, right? This will make it about $10, something like that. Anyway, but you got the idea. Yeah, just think that it's working. I hope you'll find this code useful if you'd like to make a program that will help you return the coins to the customer with minimal amount. You could use that, I suppose. It will be a little neat feature. Okay, so I will post this the source code on the website if you'd like to download it. Okay, and finally, thanks for watching and have a nice day. Bye bye.